Hi Bobcats, it's Miss Lee again, and we're continuing our linear relationship series. This video is going to be talking about independent and dependent variables. Please make sure you have your notes and that you fill them out completely. Pause the video if necessary. Many real-world situations involve two variable quantities in which one quantity depends on the other. These quantities are called independent and dependent variables. It is important that you be able to identify the independent and dependent variables in a linear relationship when given a situation, a table, a graph, or an equation. The independent variable, which is our x variable, may have its value freely chosen without considering the values of any other variable. Okay, so x is the number that can change. You can choose any value for x. And one thing that's important to note is that time is most always an independent variable. The dependent variable, which is your y variable, depends on the other variable. It depends on the x value. You cannot determine the dependent or the y value without first knowing the x value. And when you're looking for the total of something, that is most always the dependent variable. So let's do a couple of situations. You burn 14 calories every minute that you exercise. Okay, what are the two things that you're comparing? You're comparing the calories that you burn, and you're comparing the minutes that you exercise. So which one do you think is going to be independent, and which one do you think is going to be your dependent? Well, you don't know how many calories you're going to burn unless you know the number of minutes you exercise. So the minutes that you exercise, this is going to be your independent. Also, minutes is a form of time, and time is usually always your independent. And then the calories you burn is going to be your dependent. Our second example, 2 slices of pizza per person. So we're talking about slices of pizza, and we're comparing that with the number of people. Which one is your independent? Which one is your dependent? Well, total slices is kind of like a total, right? So that's probably your dependent. And the number of people, you need to know the number of people to determine how many slices of pizza you need, right? So your independent would be the number of people, and your dependent would be total slices of pizza. Okay, $7.50 per movie ticket. What do you think? Which one is the independent? Which one is the dependent? Well, first, what are the two things you're comparing? We're comparing the number of tickets to the total cost. That's right. The number of tickets is going to be your independent. The total cost is going to be your dependent. You don't know how much you're going to pay for tickets unless you know how many tickets you have to buy, right? Okay, so the number of tickets is the independent. You could buy 1 ticket, you could buy 3 tickets, you could buy 7 tickets, but you can't figure out the cost unless you know the number of tickets. You can also look at a graph and determine what is the independent and what is the dependent. The main thing to remember is right here. Whatever is on your x-axis is the independent. Whatever is on the y-axis is your dependent. So looking at the graph over here, the clay used in art class, your independent is going to be the clay that was bought by the teacher. This is your independent because it's on the x-axis. Okay, the clay that's available is going to be your dependent because it is on the y-axis. You have to know how much clay was bought to determine how much clay each student is going to get. We have another graph here, same thing. This is your x-axis, even though it's not labeled. So the time in hours is your independent. The y-axis, your vertical axis, this is the total money earned. This is your dependent. You don't know how much money you earn unless you know how many hours you work. And you can also determine your independent and dependent variables by looking at tables. Okay, in most tables, the first column, if you're looking at a vertical table, is your X, which is your independent. The second column, total cost, is usually your Y value, which is your dependent. And the same thing for horizontal. X is usually first and Y is the second row. So X is always your independent and Y is always your dependent. So again, if you're given a graph, you're given a table, you can easily identify what is the independent and which one is the dependent. Okay, so let's do some independent practice and kind of throw it all together. Everything that we've learned in the first video, part 1, with the multiplicative and additive relationships and with proportional and not proportional, and then this video with the independent and the dependent variables. Okay, we have the situation. Nicky completes chores and his younger brother Alex helps. Their parents pay Alex first and then pay Nicky, who always earns $2 more than Alex. The graph shows the relationship between the amounts Alex and Nicky earn. First, we want to identify, is this a multiplicative or an additive relationship? Okay, we could look up in the situation, in the word problem, and we could try to figure it out ourselves, or because we're given the graph, just look at the graph. Look at your line. Does it go through the origin? No, it does not. And remember, if it does not go through the origin, that means it's what? Additive. If the line does not go through the origin, it is not multiplicative, it is additive. And if it's additive, does that mean it's proportional or non-proportional? Non-proportional. And then what is the dependent? Look at the graph. Is the dependent going to be on the x-axis or is it going to be on the y-axis? It's going to be on the y-axis because it's the dependent. So who is dependent? Nicky's earnings. That's all there was to it. Pretty simple, right? Let's try another one. The graph shows the relationship between the independent and the dependent quantities. So which set represents all the independent quantities that are shown in the graph? Okay, go ahead and make your selection. Okay, did you choose C? We're talking independent. Independent is on your x-axis. So if you look, our first point is at 0. Our second one, if you go down to the x-axis, it's at 1. The next one is at, 2. Then you go down, we have 3, 4, and then 5, which is why C is your answer. Nice work, Bobcats.